All right, so good morning, everyone, and thank you for giving me the chance to present this work. So my name is Olaitan, and currently I'm the training officer for the African Society for Bioinformatics and Computational Biology, ISBCB. With them, I'm also a bioinformatics independent consultant. Okay, so this project is Prostruc. It's a tool that we developed for 3D structure prediction using homology modeling techniques. It was a project as part of the Omics Codathon that was run last year, the October Omics Codathon. Okay, so what I will cover as follows: the background of the work and just some introduction to homology modeling, the method we used, what we got as a result, and just some discussion. So as of the latest data, the UniProt database contains over 250 million protein sequences, and the Protein Data Bank, which is a database of structures, contains over 200,000 experimentally determined protein structures. So homology modeling, as we know, is a comparative modeling technique to predict 3D structure of any given protein based on its sequence similarity to one or more known structures. And being able to accurately do this protein modeling is quite essential for drug discovery, protein engineering, functional annotation of genomes, and the likes. So we have some existing homology modeling tools, as we know, like Modeler, Fire2. We know of the latest release of AlphaFold. And these have been widely used and have an avenue for various research in bioinformatics, as we know. So our idea was not necessarily to beat, for instance, AlphaFold. So in a hackathon setting, what we're trying to do is build a prototype of a tool, if what we're doing is tool development. So in the Omics Codathon, for instance, we have different themes. It's a multi-themed setup where sometimes we have teams working on maybe bulk RNA-seq, looking at potential biomarkers for some type of phenotype. We might have some teams working on metagenomics. Some might prefer to do computational drug design, and have teams that are developing software pipelines. We even have sometimes hardware packages being developed in these events. So this particular team was just focused on developing a tool that will be based on Python that will do 3D structural prediction using homology modeling techniques. So what we wanted to achieve was just come up with that tool at the very least and see if we can achieve something that kind of at least matches what we have that exists. Some of the existing tools, because we did some literature review to see what exists out there, require substantial computational resources, specialized software installations, different ways of interacting with the tool. We then figured out, let's have a tool designed that will be user-friendly. So we have a web interface component of that tool, and then we'll have a command line component of the tool as well. And will be a one-stop shop for 3D structural prediction. Okay, so we have different algorithms, like I talked about. Some of them specialize in a certain protein type. Accuracy and precision of prediction is also sometimes an issue. Then we were looking at, okay, can we integrate these steps together and have everything just happen in Prostruc and make it open source as well, and not necessarily like closed source. So multiple tools exist, and the ease of use was our focus. So regardless of where you are in bioinformatics, your level of expertise, you should be able to use Prostruc. That was also something. And like I said, a one-stop shop for all the steps of protein structure prediction. So objectives: automated tool, user-friendly, come up with a workflow that utilize existing open source libraries to do structural insights, protein structure specifically, rather, insights. And then we were trying to work on speed and accuracy for the prediction. So I will show you the workflow. So here's the workflow that we followed for this. So the first step is you have an input sequence. You can actually just have your text of the FASTA sequence for your protein and just put it there. So there are two modes. There is the command line. You can just do your Prostruct, put the necessary argument, and copy the text to that flag that is expecting the FASTA sequence. If you're using it from the command line, but from the web interface, you can either upload a FASTA file if you're using that mode, or if you're using the mode of entering the sequence, you can actually just copy the protein sequence and paste it there also on the web, and then do your job submission. You get an email right off the bat telling you that they've received your job and you have a job ID and stuff like that. I'll show you a screenshot of the email shortly. Then we get into pairwise sequence alignment. So we do a template search. We actually have a protein sequence analysis step prior to the sequence alignment step, where we're just giving you different parameters of what we found in your protein of interest. Then we do the pairwise sequence alignment, do a template search, and we are going to use Promo 3 for the homology modeling engine and give you two templates where you can pick one of the two templates. We evaluate our predicted model using TM score, RMSD score, to do a first stage evaluation. If it passes, because we are actually returning to you the top 5 models. If it passes the first stage, you might go down to maybe from 5 to maybe 3, for instance. Then we do the Q main disco score and give you the best prediction that we have. Okay, so this is the protein analysis report that you have on the left side of the screen. And then we just give you some parameters of your protein sequence. Okay, so this just shows a kind of graphic interface of what I just described. So we have 5 models, and then you just, at the end of the day, we return the best model. So for reliability and accuracy and efficiency of Prostruc, Prostruc is being validated and optimized using popular models like Swiss model, Modeler, and the likes. We also did, our tool uses the QMIN Disco, RMSD, and TM score, but the existing tools use those other metrics for validation of the model. So Prostruc is more, I would say, easy in its approach of doing homology modeling. Okay, so this is a typical example of what you have in the command line. The first one is just how to install Prostruc. So you can install it through pip, just doing pip install Prostruc, and you have it installed on your computer. We do have a Docker container for Prostruc actually on the Docker Hub. There's a GitHub repository for Prostruc. So if you, and there's a paper for Prostruc as well that I'm going to show us. So if you do need any information about maybe installing it, running it in the command line, or using any of the tools out there that we made for Prostruc, those things are actually, materials are quite instructive. The example below is just how to run Prostruc from your command line, which is Prostruc. The argument that takes the sequence, the protein sequence, is the -- sequence. Then you have the -- job name to just name it, the job however you want to name it. And then -- email, you provide Prostruc with your email address. It runs on an AWS instance where an email is sent to you once you get the job submitted, whether you run from the command line or through the web interface. Okay, so this is an email, that was sent. I did make a job submission, and then I'll get an email there, Prostruc user. You have that. It just gives you your job name, job ID, so you know that your job has actually been submitted. So we have a paper, like I said, for Prostruc, which is where you can read about it, and a lot of the technical details about the methods are actually well documented right there. So what did we contribute to the field? Integration of 3D structure prediction pipeline into one software, like I said, was the main goal. So you don't have to go all over the place to do the different steps to find what's in your protein and things like that. So we're doing protein sequence analysis, and of course, we're doing we have an integrated homology modeling engine in Prostruc. So more to the applicability, drug discovery, vaccine development, understanding protein interactions, are more done, through tools like these. Structural comparisons across homologs can reveal evolutionary adaptations. Bioinformatics research, especially large-scale projects requiring automated homology modeling, now is more enabled using tools like Prostruc, which performs protein structure prediction with ease of use being our focus. So it's customizable, scalable for large studies, and open source encourages the community in collaboration and ongoing development. So things we are looking at doing more, this is more of a next step actually. Find a way to incorporate a visualization component into Prostruc and increase its speed and accuracy of prediction. So we designed Prostruc as a one-stop shop for efficiently doing homology modeling, and it's freely accessible. It's out there. The GitHub and all the code and everything is actually also open. So we have a flexible and user-friendly interface. So this is the team that developed Prostruc. So Wilson was the main developer for Prostruc. Shivani basically was the one driving the science. And we have Musa, Tohib, Nigel, Abdulwasi also as other members of the team worked with them. I was providing guidance, resources, and getting the project to move forward. Okay, so in terms of acknowledgement, some of the things that I do, I'm very passionate about bioinformatics outreach, just for what it's worth. My hopefully goal is that we'll have more bioinformaticians from within Africa that are pushing the science, and we'll have more Africans that are doing the data analysis and every other step of bioinformatics. I have people that do support in some of the things I do, like Shivani, Chenemi, Kimberly, that we probably have met in the course of this conference. And I do want to acknowledge the African Society for Bioinformatics and Computational Biology for kind of providing a platform for running the Omics Codathon. The Omics Codathon itself is a program, but then the ASBCB is basically just a platform for running that program. So Biodata Sage also provides support, cloud instance, and some other kinds of support. Sometimes there are some other entities that do provide support as well in doing the different things we do in the Codathon. We've had support from the NIH ODSS. We've had support sometimes from the EBI. I would like to acknowledge the ISCB for providing me a travel fellowship for this conference. And if you are interested in supporting the Omics Codathons more, I have my email there. Please feel free to reach out. I'm always eager to hear about what people want to kind of do to support the Omics Codathons. The past Codathon projects, we have them on asbcb.org/events right now. If you want to read the Prostruc paper, feel free to scan the QR code, and thank you very much for your attention.
Thank you. We've got time for the question or two. We've got one in front to start.
Thank you for the presentation.
Sure.
Yeah. So we know that there are actually a lot of tools that could help for building the homology model. And then actually even one built in Prostruc University by Open Bishop. It's called Primo. Could you expand a bit on the benchmarking in terms, for example, of computational analysis, computational time, or accuracy, or the data set that we used for testing this tool compared to the other fields.
Okay, thank you very much. So what we notice is that the RMSD score so we're just benchmarking mostly on the validation metrics to see how we performed. Like I said, we weren't planning to really beat the big tools out there, like Alpha Forward or this other one you just mentioned. But we're trying to see, can we have maybe a better score for this metric, like maybe RMSD or K-mean score and the likes. And for the tools that we did use, some of the tools that I had shown earlier, like the Fire, and I think some of the other tools, they are right there. I just didn't put the table on this slide because it's a very giant table, but it's in the paper. We did comparison. We listed the features of each of these tools, and then we listed the features that we have in our tool and explained some of the areas we did well. I don't believe that we have the best accuracy, but there were metrics that we did better than existing tools like the RMSD, like I talked about. So that was it. It was just a one-stop shop idea for homology modeling. That was what we did, not necessarily like beating them in accuracy, which was why I said one of the next steps is increase the speed, increase the accuracy. Thank you.
We'll take one more question in the back.
Yes, thanks, Samuel. Thanks, Chef. Sort of a general question in terms of the templates that we use for the modeling. Usually we look at S3 structures. What is the prospect of using NMR structures, generated structures, in the light of the fact that they offer these dynamics? Do you see that happening when it comes to really using those templates in terms of generating structures?
Yeah, we didn't look
No, it's a general question.
Okay, oh, I see. Okay. Thank you very much. We didn't look at that.
All right.